So I need concave up, meaning I need to find second derivative, okay? And if it's increasing, I'm finding first derivative. So let's start with the first derivative. We have f prime of x is equal to, when I derive the negative 3, it's going to give us nothing, right? What's the derivative of 6x squared? 12x. What about negative 2x cubed? Minus 6x squared. And then I want to set this equal to 0 and take out our GCF. Our GCF between 12x and 6x squared is how many? 6x. And then I have remaining 2 minus x. So I have two critical points that I'm going to test. So we have infinity and negative infinity. My 2 points are at 0 and also at where? 2. Okay? So we have 0 and 2. And when I'm plugging it in, we're plugging it back into this component because all we care is if it's positive or negative. So let's see what numbers to test. I think I want to test 1. What number should I also test on the right side? 3. And then on the left side, negative 1. So if I plug in negative 1 into my first component, I get negative. Second one, I'm going to get positive. So negative times a positive, our graph is going down. And I'm hoping you know how to plug the remaining in because I'm not going to show that part. Up and down. So it says, when is the graph increasing? We're looking at this guy over here. And we're going to save that for now. Look at the second derivative next. So my second derivative. And let's derive from the original polynomial. 12x gives me what? 12. Negative 6x squared gives me 12x. And again, I'm going to set this equal to 0. You can factor out if you want to, but then for this one, you really don't have to. Let's do this mentally. If I move this positive 12, I get a negative 12 on the other side, correct? That negative 12 divided by the same negative 12, I'm going to get what?
1.
So 1 is our critical point. So here's my 1, here's my infinity, and here's my negative infinity. Let's test two numbers. Let's do 0 and 2. So when I plug in my 0 into this, we're going to get positive, correct? So we know it's going to be concave up. And when I plug in the next one, it's going to be concave down. So the interval that I'm looking at is this right here. Now, because I like things graphically, I want to graph them at the same time. You don't have to if you see the answer, but I want to. So we had 0 to 2. Here's 0, here's 2. And I'm going to highlight that piece. And then we have our 1 was the other critical number. Here's my 1, negative infinity and positive infinity. And where I have circled is from negative infinity to 1. So if I highlight that piece, which one is double shaded? Boom. So this one might take a while, but it is doable. Okay, number 17. Tim, let's read.
A particle moves along the x-axis so that at time t is greater than 0, its position is given by x of t equals 12 e to the power of negative t sine t. What is the first time t at which the velocity of the particle is 0?
Okay, let's rewrite this with the parentheses since it kind of helps me understand it is a product rule. That's a t, by the way. Sine of t. So let's practice our product rule. And we're trying to figure out when is the velocity of the particle 0. So if that's a particle, the derivative is our velocity. So we have x prime of t is equal to, I'm not going to have enough room. I can already tell. I'm going to go all the way over here. So let's use our product rule. What is the derivative of 12e to the negative t? Negative 12 e to the power of negative t. Are we okay with that? Because derivative of e is itself times the derivative of its power. The power negative t is going to give me negative 1. Good? And then we keep the second piece, which is our sine of t. And then what operation separated this? Plus sign. And I keep the first one. And then we derive the sine. What is the derivative of sine? Cosine. Now, just to kind of avoid confusion, I'm going to rewrite this. I'm going to move the first one to the right one to the left for a good reason. If you don't want to do that, that's fine. Something about having a positive value at the beginning allows us to think a little bit better, at least for me. Minus 12. So I need to figure out what my GCF is between this component and the other component. What is common between those two? They both have 12e what? Good. 12e to the negative t. And then I'm going to put the remaining back. Cosine of t minus sine of t. And I need to set this one equal to 0. So that means set the first factor equal to 0 and second one equal to 0. But something interesting happens on the first one. 12e to the negative t is equal to 0. Back long time ago, even on unit 3 or 4, e to whatever is always what kind of number? It's always positive. So this is irrelevant. That's not going to help us. But the next one is going to help us. If I say cosine t minus sine of t equal to 0, I can move them over and say, well, then when is the value of cosine t equal to sine of t? So if you think about your graph, where do I have where cosine and sine are always the same? At pi over 4. At pi over 4. And that's going to be a. Anyone need detail of pi over 4? Or are we okay? We're good? Okay. Let's move on to number 18, where we're going to use second fundamental theorem of calculus. This one should save you like 30 seconds. Hopefully. Okay, Bailey, let's read.
Let f be the function given by f of x is equal to the integral from 3 to x tangent 5t secant 5t minus 1. Which of the following is an expression for f prime of x?
Okay, so if you're wondering, this is from flashcard number 9, and I believe it was the front. So when you're studying for this, do refer back to the flashcards. So we have to plug in the upper bound with x, wherever I see my variable. And at the end, I'm going to derive the x, which is 1. So let's write big F prime of x. And because I'm thinking ahead, I'm going to use a bracket. Tangent of 5x. Secant of 5x. Minus 1. Close my bracket. What is the derivative of my upper bound? Times 1. When I subtract, no matter what I do, in the end, I'm going to derive a 3, right? What is the derivative of 3? 0. We don't need it. So then what's the best answer that's going to match this? D it is. Number 19, we're looking at tangent lines. So Addison, let's read number 19.
Let f be a function given by f of x equals to cosine x plus 1. What is the approximation for f1 found by using the line tangent to the graph of x at x equals pi over 2?
So my tangent line, we need x1 and y1. We also need a slope. The good thing is they gave us the x, so we have pi over 2. To find the y1, all I need to do is plug this back into the original function. So let's do that. We have f of pi over 2 is equal to 2 cosine of pi over 2, and then plus 1. And I want to focus on cosine pi over 2. So if I were to draw my chart, and I have my pi over 2 right here, the order pair of that pi over 2 is 0, comma what? 1. And cosine is 0 or 1. Cosine is 0, so we know the y1 value is 1. Now we have to find the slope. Slope is the derivative, right? So let's do f prime of x. What is the derivative of 2 cosine of x? Is it positive sign or negative sign? Negative 2 sine of x. Now I need to plug in the x value given. Pi over 2. We have negative 2 sine of pi over 2. What's nice is I already have pi over 2 done for us. Sine of pi over 2 is how many? Is it 0 or 1? 1. So we know this is going to be negative 2. So my point slope formula from, I believe, even algebra 1, right? Y minus y1 is equal to my slope negative 2 times x minus x1. And then they said All right, now plug in what number? Now plug in 1.5. So y minus 1, negative 2, 1.5, minus pi over 2. And if that decimal is scaring you, it shouldn't, because if I double 1.5, how many is it? Good, negative 3. And if I take the 2 and divide it by 2, doesn't that cancel each other out? Yep, and we have two negatives plus pi. So our final answer is y is equal to negative 2. Is it negative 2? Yeah, plus pi. And I know if we reverse it, it's going to be pi minus 2, which is which one? C. 20, if any, might have been confusing, but there is a way. If you ever get stuck, because last year when y'all did rational functions, graphing, it kind of got hard, right? Especially with the absolute values. The easiest thing for you to do is pick out a number and make a t-chart. You can just plug in numbers and see what the graph is doing. Okay, so let's do that. I'm gonna let the answer choice be my hint. I know I have to let x equal what no matter what according to the answer choices. 2. So what I'm gonna do is pick few numbers before 2 and few numbers after. Good? So let's make our t-chart. So we have x and y. I know I have to use 2. So why not do 3 and 4? And then why not also do 1 and 0? If you're curious as to what's happening on the negative value, you can, but it's not really going to matter because you'll see a pattern. So I'm going to show you how to plug in the first one. Here's my equation. When I plug in my 0, I get 0 minus 2 all over 2 times the absolute value of 0 minus 2. My top is going to give me negative 2. On the bottom, in the inside, my absolute value, I get negative 2. And the absolute value means no matter what, it's going to change to what kind of sign? Positive. So 2 times the positive 2 is how many? So that means we have negative 1/2. So I'm going to give you 30 seconds to plot the remaining and see what happens. And one of them is going to be undefined. As you find them, go ahead and graph the points. Someone give me the y value at 1, negative 1/2. Did anyone find a value at 2? That was undefined. Anybody for 3? Not yet? Half? And then 4 is also 1/2. So let's go ahead and graph this. So 1/2, negative 1/2. Undefined, I can't graph that. So 1, 2, 3, 3/2, 4/2. So you might realize a pattern is doing something like this. On the left, it's going to forever collect negative 1/2. On the right, it's going to be forever 1/2. So just by looking at this, oh, there's a mistake here, right? 2. As it approaches 2. Oh, we just can't put a solid dot on that one. It still go into it. So just by looking at this, do we have a jump discontinuity? Yep. So again, if you get to a graph that is ugly and you forgot pre-cal, it's okay. Okay? Let the answer choice be where you start and pick 2 numbers above and below. Good?